One of the most intriguing aspects of a NURB surface is the fact that while you're working with them, and when you render them, you never really get to see them. What you're looking at in the viewport and at render time is a polygon approximation of your NURB surface. What I'm going to do in this video is show you how you can control that approximation to adjust the accuracy of your NURB surface at render time. Now let's begin by creating a NURBS surface, and what I'll do is we'll come over here to the side view, and I'll grab my CV curve tool. We'll make a really interesting looking curve. I'll duplicate it, grab both curves, make a loft, and delete out my curves when I'm done. So here is my super interesting NURBS surface, like so. Now, when I grab this object and I zoom up on it, you'll notice there are some little straight lines here. This is not perfectly curved. The reason those lines are there is because in the viewport we're seeing a polygon approximation of the surface when we look at the shaded view. When we hit render, you'll notice the same thing. There's a little bit of nickeling taking place here. We see a straight edge and a straight edge and a straight edge. That is because, again, you're looking at a polygon approximation. If you open up your attribute editor, you have a tessellation area, and this allows you to control how your NURB surface is tessellated. Now, I'm going to be keeping this relatively simple because a lot of the options that are talked about in here are covered in more depth later on when we start talking about converting NURBs over to polygons, so I'm not going to get too bogged down here. First off, we have display render tessellation. If you switch this on, you get to see what the rendering engine sees. So when you hit render, this is what actually renders this polygon shape that closely approximates our NURB surface. So we'll go ahead and leave that on so you can see what we're actually doing here. So under tessellation options, we have two different types of tessellation. We have simple and we have advanced. Now, let me go ahead and I'll just start off by talking about our simple tessellation options. First thing we have is curvature tolerance. Now, on the surface, what this is going to do is allow you to control how smooth your surface looks. I can set it to no curvature check, which we just get some very basic sampling. We can go to low quality, medium quality, high quality, and highest quality. You'll notice each time I go up, we get a smoother flowing surface. We get basically more polygons to tessellate the object out. Now, internally, this is adjusting the chord height ratio, which is the ratio between the distance from a NURBS curve to the edge that is approximating it against the distance between the 2 points of the polygon edge. Now, that may be a little bit technical, maybe a little tricky to follow. Don't worry, that aspect of tessellation is covered in much greater depth along with visual examples later on when we start talking about converting NURBs to polygons. Right now, I just want you to remember that curvature tolerance is internally adjusting the chord height ratio, which we will see again here in just a couple of seconds. Now, we also have the U divisions factor and V divisions factor. This is actually a multiplier for the per span number of isoparms, which is an attribute we'll see a little bit later. And basically what this boils down to on your end is you'll notice the higher you slide this number, the more polygons you get until you have a very closely represented surface. Now, whether you're using advanced or simple, there are some common tessellation options you can use either way. And we have the ability to smooth out an edge. Notice as I click this, Maya automatically adds more tessellation at the borders of the object to make the edges appear more smooth. And I can adjust the ratio to control that smoothing. You'll notice as I crank that up, I get a lot of tessellation right there at the border. It's just to make sure you don't see any nickeling there. This is an option you don't necessarily have to use it. Now, that is simple tessellation, along with the common tessellation attributes. Let's go ahead and take a look at advanced tessellation, which if you open this up, you can't really use anything inside of it. You have to enable advanced tessellation. So let's open up primary tessellation attributes. And we have two modes and two numbers. We have mode U and V and number U and V. The mode is going to control how Maya is actually performing the tessellation. By default, this is set to per span number of isoparms. That means each span of the NURB surface is getting X number of polygons. And you can actually kind of see that taking place here, where we only had one span running in the V direction, and it's set to 3. And we have 1, 2, 3 isoparms, if you will, running along this direction. So in this case, each of the spans also in U is also getting 3, but because we had more spans running in the U direction, we end up with a lot more. Now, as I slide this up, you'll notice I get much more accurate results. at the cost of much greater tessellation. This will, by the way, naturally crank up your render times. So, if you plan on using something like this, now this looks beautiful. I mean, that's a wonderful surface at render time, but it took quite a bit longer to render than if I'd kept this a little simpler. Now, from here we have per surface number of isoparms. What this is going to do is read the parameterization of the object, so how close together your isoparms are on the NURBS object, and it's going to use that to control how close together your polygon edges are as well. So you'll notice in areas of tighter curvature where you have more isoparms, you end up with a tighter density of polygon edges at the same time. You also have per surface number of isoparms in 3D. This doesn't pay attention to how dense your isoparms were on the surface. This tries to give you generally, I guess, what would be the best word? More evenly spaced out triangles across the entire surface. And in this case, you're probably going to notice that they start to get a little dense here toward the edges. That's just kind of how the system works. This is going to be a little easier to see when you start actually converting, and you can switch over to quads. The final method is best guess based on screen size, and this is a dangerous one because I've seen a lot of students who are maybe new to this, maybe a little bit on the lazy side, thinking, ooh, Maya will take care of it for me. That's great. It's not so great, because what this means is Maya is going to, at every single frame, see how big the object is in the screen, and it's going to retessellate based on the object's current location, how much screen space it's taking up. Why is that a problem? Watch this, and I'll explain real quick and easy. Let me go ahead and do a render. And we'll go ahead and save that render. Now, let me zoom way back till we're almost outside the clipping plane. We'll do a new render. And we'll save that render too. Now, if you look, it just looks like a smaller version of what was there. But check this out. When I zoom back in, look what happened to the tessellation. The tessellation has changed. A second ago, it was all dense, wasn't it? Don't you remember? If you don't remember, watch really close. In fact, ignore the render screen. I'll slide it completely out of view. Just watch over here when I hit the render button. Boom. It retessellates to give you a higher density object. The problem with that is, while you're animating, if you were doing a zoom-in shot, the tessellation would constantly be changing as you move forward toward the object. So you'll see popping. You'll see the object sort of, constantly kind of change shape and jitter, and you don't want that. If you're doing still shots, still renders, best guess based on screen size is fine. If you're doing any sort of animation, do not touch this setting. Stick with per surface number of isoparms or per span number of isoparms. Now, down from here, we have secondary tessellation attributes. This is where you can activate the use of the chord height, which is the distance from a polygon edge to the NURBS curve that it is approximating, and use chord height ratio, which is that distance from a NURBS curve to the edge that it's approximating, and the distance between the two vertices of that edge to begin with. And really what this boils down to you is, as far as just the end user is concerned, if we bring our chord height in this case isn't going to give us much of a difference just because we've already got so much tessellation, but in fact, what you're going to notice is that chord height ratio will supersede your chord height. So if we just use chord height, you'll notice the lower our chord height, the more tessellation we get. That is because essentially we're telling Maya that we will only allow a very small distance between a section of NURBS curve and the polygon edge that is representing it. And again, we'll be talking more about chord height later on when we start talking about converting surfaces. The greater I allow my chord height to be, the less, basically the greater distance I can have between a curve and the polygon edge that's making that curve when it's tessellated, and so we end up with fewer polygons the higher we go. If I switch on chord height ratio, we get the opposite, but it's because the number's been swapped in Maya 7. The higher we go, the greater tessellation we get. And for now, that's all I really need you to know. This is more of a fine-tuning method using chord height ratio. You can also use min screen, and this is very much like best guess based on screen size, except that now you have the ability to scroll back up and you have refresh tessellation, so you can move your camera and refresh. And Maya's thinking right now, so it thought. I should probably turn down my settings a little bit. It's not going to help too much. And if I move way back and we refresh, boom, we get very simple tessellation. If I zoom way in and refresh, we get much greater tessellation, but only in the area we're looking. So again, very cool for still renders. It's kind of a way to help Maya make automatic decisions for you. But when I'm animating, I never use this because it will result in popping. So that's really everything there is to controlling your tessellation. This is going to be really important to make sure that you don't have seams popping up in between two objects. If you ever do come up with seams between any two objects, try to make sure that they have the same tessellation. Like in this case, if I were to let's grab my pivot point, hold down D, I'll hold down C, and let's click on X, and I'll just curve snap this right out to here, and then I'll curve snap it right up against here. So these two objects are touching, and if I render, they appear to be contiguous. You don't even see the gap in between the two. But if I take one of them and I change its tessellation, then as soon as I render, we start seeing gaps. So whenever you're trying to take multiple patches and render them out, make sure they have the exact same tessellation so that you have nice alignment of surfaces. That's going to wrap things up for this discussion. Thanks a lot.